Hi, Sydney.
Hi, Sydney.
All right, here we go. Hope you're feeling better.
Watch the
She might. She said she might.
We all say that.
Oh wait, we should put a
Okay.
secret word somewhere in the video to make sure she watches it and ask her what the word was.
Secret word. What's our secret word going to be?
Wait, we can't say it.
No, so, yeah.
Spell addict.
No, she's got to watch the video. So what's our secret word for?
Spell
Spell
the
addict.
spelling of addict.
Yeah, spell
So
addict.
spell it.
Spell.
No, not spell addict. Spell addict.
Like you spell addict.
You spell addict.
No,
okay?
no.
So our secret word, she has to say addict?
No, you just spell addict, Dad.
No, say it out loud.
A-T-T.
No.
What?
Wait,
All
I don't
of it.
get this.
That's an at.
No,
I
without.
don't think there's a K.
There's no K.
Okay.
Okay. Just spell that.
Good enough. Anyway, Comco. Today we're going to talk about complex numbers,
Who did that? Oh, I
imaginary numbers, and I. Okay? So before we start anything, a little bit on the side, the square root of -1 is I. Okay, so whenever you see the square root of -1, you're going to write I. For example, a little bit of work on the side, I'll show you what I mean. So if I had the square root of -25,
Negative 25I. Or 25I.
It's 5I.
it's just 5I.
Oh.
And you can see it because you can do this, right? You can do this. And you know 25 times -1 is -25. Square root of 25 is 5, and the square root of -1 is just I, okay? That's an imaginary number, okay? 5I. Now, example 1 is a complex number. Reals go with reals. Imaginary goes with imaginary. This is this easy. It's just going to be 7
That's awesome.
plus 3I. That's it. 7 plus 3I.
Wait,
Done.
Wait, no. Oh,
Done.
wait, no.
And you cannot combine these. That's a real number and imaginary. You have to keep them separate, okay? Example 2, same thing, except we're going to subtract, all right? You can bring through the negative if you're nervous about negatives, but if you're okay, then we're going to have a 3 minus a 4 is a -1, and a 5 minus a minus, double negative, right? Which is like plus, is going to be a positive 7I. Now, if you're not sure if you're going to mess up on your negatives, then just bring the negative through. Remember how we brought the negative through?
Yeah.
If I brought the negative through, I would have a, bring it through, I'd have a -4 plus 2I, right? And then it's easier to just add the 3 plus 5I if you bring the negative through. You don't have to bring it through. Hopefully you can see that, okay? Now, number 3. Now, if the square root of -1 is I, then I squared is -1. I squared is -1. So you go from an imaginary, when you square it, it becomes real. I'll say that again. You go from an imaginary number, and when you square it, it becomes a real number. That's kind of significant, okay? So in number 3, we're going to FOIL. 4 times 3 is 12. 3 times a -2I is a -6I. 5I times 4 is a positive 20I. And 5I times a -2I is a -10I squared. All right, now we're not done because we can tidy up some things. Now, first two things. One, we can combine the two imaginaries. We can just add those two together. You get a 14I. But the second thing we do is, if it's an I squared, we're going to change I squared into the number 1, -1, right? So, 12. Let's combine the two imaginaries. We'll have a positive 14I minus 10, and we're going to change I squared back into -1, okay? So you see I squared, just write as -1, okay? Then I'm going to simplify. I got a 12 plus a 14I plus 10, right? Just plus 10. And then combine them, and so you're going to get a 22 plus 14I. Now, the standard form of any complex number is real plus imaginary, okay? This is the way you should write it. If you wrote the 14I first, I wouldn't count it wrong, but it should be real, then imaginary, okay? It should be A plus BI, okay? It should be. If you don't write it like that, I won't count it wrong. But the proper way to do it is real plus imaginary. How am I doing? Now, I to the 23rd. Now, let's go through this. Okay? It's, well, if I squared, let's go through this. If I is plain old the square root of negative 1, and we know that I squared is negative 1, right? What's I cubed going to be?
9?
I don't know.
What's I cubed? Negative I.
What?
Because it's going to be I times negative 1. Right? Okay, real quick. I cubed is the same thing as I times I squared. You okay with that? And so then we know that I is going to be just plain old I, but I squared is negative 1, so it's going to be a negative 1I. Okay, so I cubed is negative I. Okay, then what about I to the 4th? What's I to the 4th?
Wait.
What's-
I to the 4th is I. Right,
Nope.
Evan?
Nope.
I, negative I. Negative 1 squared.
What's I to the 4th?
2i. Negative 2i.
What's I squared? What if I give you a hint? I squared times I squared.
I to the 4th.
Oh, it's negative. It's just
No, 2i to the 4th.
I.
2i to 7.
Wouldn't it be negative 1 times negative 1? Would it be negative 1 times negative 1, which is what?
2.
Positive 1. So let's write this on the side, okay? Let's put this on the board.
I to the
Here's what
4th
we
is
know.
just 1.
Yep. So let's write on the board. Okay, so I is just I. I is just I. I comes from the square root of negative 1. I is just 1. I squared is negative 1. I cubed is negative I. I to the 4th is
Yes.
1. Plain old 1, okay? So let's put it on the board. Okay, we got it. Okay, now. So far, okay, so I is just I. It comes from the square root of negative 1. I squared is the number, real number, negative 1. I cubed is negative I. Okay, we showed y here. I to the 4th is positive 1 because it's negative 1 times negative 1, okay? Now, what about I to the 5th?
No one cares about I.
Yeah, we do. Okay, what about I to the 5th? What about I to the 5th? Come on, I to the 5th.
2.
Say it.
Negative I.
It is I to the 4th. Oh, shoot. I to the 4th times I, right? What's I to the 4th? What's I to the 4th?
1.
Well, I to the 5th is what?
1i.
1I.
Wait, isn't that the same
1
thing as...
I.
Okay, I to the 6th.
Wait, so it's just I.
What's I to the 6th?
2I.
Oh, no, negative 1.
Negative 1. Because it is
my gosh.
I to the 4th times I squared. I to the 4th is what? What's I to the 4th?
Wait.
1.
But so is I to the 2nd.
Right, because that's...
So
your-
it's just a pattern repeating over and over.
It's just
again.
a
Yes,
little-
I'm getting you there. Thank you. Yeah, we're
Oh,
getting there.
thank
So
you,
it's going to be
Landon. Big
1
clap for
times negative 1, which is a negative 1, right? So I to the 3rd, or I to the 7th. What's I to the 7th?
Negative I.
Negative I. Because I to the 4th times I to the 3rd. I to the 4th is 1, right?
I to the 7th.
And I to the 3rd is negative I, right? So then
This is getting really complicated.
if we go all the way to I to the 23rd, we know that I to the 4th, here's the key, I to the 4th is 1. Right? I to the 4th is 1. Everybody agree with that? So I to the 23rd is the same thing as I to the 4th times 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 I to the 3rd. Okay, now that's kind of a pain in the rump way to do it, but it shows, okay? These are all just ones, aren't these? These are all just ones. 1 times 1 times 1 times 1 times 1.
20.
This is what?
1.
Just 1.
That's 27 eyes.
I didn't put too many other.
I only have 2 eyes.
1, 2, 3, 4, 5. That's 20. 4 times 5 is 20.
Oh.
Okay, right?
Whoops.
Okay, now let's go back to this. I to the 4th is what? 1 times 1 times 1 times 1 times 1 is just 1, right? And I to the 3rd we know is negative I, okay? Or this is kind of a pain. Why don't we just write this instead as I to the 20th times I to the 30th? Isn't that a faster way to do it? I to the 20th because it's a multiple of 4, right? I to the 20th because it's a multiple of 4. This is 1. This is 1. We can show it because it's 1 times 1 times 1 times 1 times 1, right? I to the 4th is 1, so the answer is I to the 3rd, which is
Negative I.
negative I. Okay? All right.
My brain hurts.
Okay, example 5. So there is a rule. You can't have a square root in the denominator. Remember that? And you can't have a I in the denominator. So when we had a square root in the denominator, we fixed the problem with the problem, right?
Oh, yeah.
Remember that? So we have an I in the denominator. But let's fix the problem with the denominator. So I'm going to multiply top and bottom, numerator and denominator by I over I. You have to do top and bottom by the same because this is important. You have to do I over I because we're doing the rule of 1. I'm multiplying by 1. Am I not? This is 1. Isn't that 1? That's 1. So the reason I can do this is because I won't change the value of the problem. When you multiply anything by 1, you don't. That's why it's got to be top and bottom the same. But fix the problem with the problem. So let's do this. So I'm going to wind up with a 7i plus a 3i squared over a 4i squared. Did you follow that? I see some I squareds, which is the number -1. So I'm going to rewrite this as a -1 and a -1, okay, because I squared is -1. So I'll rewrite this expression as a 7i minus 3 over -4. Right? Change that to... Right, so let me rewrite it because it needs to be, I don't want to go too fast, it needs to be in this form, right? So I'm going to rewrite it as a negative, I'm going to rewrite it as a 3/4 minus 7/4 I. Okay?
Wait, I wasn't even on my phone.
Oh, well, I'll keep it anyway.
I just love it.
Okay, 6. We're getting there, okay? Okay, on 6. Now, you talked about the conjugate, didn't you, Hayden? Okay? Jaden talked about the conjugate. So, in order to get rid of the I, and first of all, if we don't use the conjugate, watch what happens. Okay, if we just go I over I just want you to watch, then I'd still wind up with an I in the denominator. See that? I'd get a 1i, right? I'd get an I squared here. I would get an I squared here. It would disappear, right? I squared is... But I would be stuck with an I still in the bottom, right? So multiplying by I over I doesn't work when you've got a plus or minus down below. So we multiply by the conjugate. Okay, that's what we learned about the conjugate. So if I multiply top and bottom, numerator, denominator, by, and the conjugate is 1 plus 2i. That's the conjugate. Okay? 1 plus 2i. Then I'm going to FOIL the top and I'll FOIL the bottom. You'll see what happens. So on the numerator, 3 plus 1 is 3. 3 times 2i is a 6i. 5i times 1 is a positive 5i. And 5i times a 2i is a positive 10i squared. Okay, I'm just foiling the numerator. The denominator, I'll FOIL. I'll get a 1. 1 times 2i is a positive 2i. Negative 2i times 1 is a negative 2i. And then negative 2i times a 2i is a negative 4i squared. Okay. Now the reason we do the conjugate is the middle term always cancels out because we multiplied it by its opposite, right? And we want the middle term to cancel because then your i's are gone. Because this is an I squared, which is a -1. So then all of the i's are out of the denominator. Okay. So we've cleared the denominator. Okay. So on top though, let's make that an I squared also. So we'll have a... So in the numerator, we'll have a 3 plus an 11i minus 10. You get the minus 10? You get the negative 10?
No, why?
I squared is
Negative.
times your 10.
Okay.
Okay. In the denominator, we'll have a 1 minus a 4 times a -1, right? tidy up the numerator. We'll have a negative 7 plus 11i over 5. You okay with 5?
What? Wait, is that negative 7 plus?
Negative
1i?
7 plus 11. Thanks, Zoe. 11i. Now, I would accept this answer, but I really don't like this answer because it really should be separate. You're supposed to separate them. So we're going to go negative 7/5 plus 11/5 I. You really are supposed to separate them because one's a real number and the other's an imaginary. They're not supposed to be together. Okay, so final answer is going to be a negative 7/5 plus 11/5 I. Okay? And now I've separated my reals and my imaginaries. Okay? It's not so bad, is it? Okay, you ready to turn the page? I'm almost done. Okay, then we'll do some homework together. Okay? Turn the page. Okay, example 7. Okay, this is why, as a mathematician, not as a PhD in electrical engineering, as a mathematician, this is why we do I. Okay, so if we solve, go minus 9, right? You're going to get x squared equals negative 9, right? Square root. How many answers?
2.
Good. 2 is right. So x is equal to plus or minus the square root of negative 9. But that's not possible, right? So I'm going to rewrite it as x is equal to plus or minus the square root of 9 and the square root of negative 1. Same thing, but I just broke it up into negative 1 times 9. We know the square root of 9 is 3, and the square root of negative 1 is I. So as a check, all right, as a check, and I want you to see this check real quick. Let's check the answer, okay? Check answer, okay? So x is equal to plus minus 3i. Let's plug in. We're going to plug in. Let's plug in 3i. Okay, if I do that, I'm going to go, okay, plug it in. I go 3i squared plus 9 equals 0, okay? So my answer should make the expression 0. I say, okay, my answer is 3i because that would make the expression 0. Well, let's do it. 3 squared is 9, right? And I squared, so I got 9i squared plus 9, right? So I'm just checking my answer. I plugged it in. What's I squared?
Negative 1.
And negative 1 times 9 is negative 9. So then you got negative 9 plus 9. Doesn't that equal 0? So it's an answer that works, and that's why mathematicians like the number I, because it helps us solve the problem. And if I did the negative, same thing, because when you square the negative, you get a positive anyway, right? So, okay, now, last but not least, number 8. Okay, take a deep breath. We can do
Number
it.
8 hard.
Well, we can't factor it.
So let's not do it.
So what do?
When in doubt, don't do it.
We're going to use the quadratic formula.
Oh.
Negative b plus or minus square root of b squared minus 4ac all over 2a. Mr. Massey said, make sure they know the quadratic formula. I go, they do, but they just need to practice some more, right? Because a lot of what he'll do in his class, you will not be able to use a calculator, okay? So, here we go. A is 4, B is negative 24, and C is 37, right? So negative B is going to be a negative 24 plus or minus the square root of B squared, a negative 24 squared, minus 4 times A, which is 4, times C is 37, all over 2A, which is 2 times 4. How am I doing? Zoe?
So we don't do anything with the x's?
No, when you do the quadratic form, you're finding, let me back you up, you're finding the answer to the x's, just like this one, x equals. And that's why it's plus or minus, because how many answers?
2.
2. And that's why the plus or minus is there. So you get your 2 answers, right?
Okay.
Okay, so I'm really going to get a positive 24 plus or minus. I'm just going to save some time here and do all that in my calculator. What is 24 squared? Can you see that? What is 24 squared? Subtract 4 times 4 times 37. That whole expression is a negative 16. So square root of a negative 16 all over 8. Okay?
Oh, wow.
Now, square root of negative 16. What are you going to do?
4i.
4i. Yes, 4i. Okay, and a little side, if you don't see that, little side work. Square root of negative 16 is the square root of 16 times the square root of negative 1, which is 4i. Nice job, Zoe. So we're going to rewrite this as 24 plus or minus 4i over 8, right? We're almost done. Can't write it in that form, so we're going to write it as the real plus or minus the imaginary. So my answer is going to be 24 eighths plus or minus 4 eighths I. And let's just finish up and reduce it, right? So how about 3 plus or minus 1/2 I? And that's both solutions. Remember, two answers. One answer is 3 plus 1/2 I, and the other answer is 3 subtract 1/2 I. Now, homework. And if you don't get the page numbers, then it's just the section 3.1 in the homework, okay? And these are the numbers, and I'm happy to help you work on this.